Well, welcome everyone. So today we're going to kind of go over repeated measures ANOVA. The majority of this we'll be talking about the SPSS output and how to run a repeated measures ANOVA test in SPSS. And we'll kind of start off with a brief explanation of what a repeated measures ANOVA is. So anyways, we'll get started. So kind of an introduction. We're kind of all aware at this point. The repeated measures ANOVA, or RM ANOVA, it's a statistical test, uses participants to provide data across multiple data points, and comparing these participants for two more conditions or two more data points. So some of the benefits of the repeated measures ANOVA, it kind of eliminates unsystematic variance. Or this is sometimes called noise. It eliminates the things that a researcher may not account for necessarily within a test. The repeated measures kind of eliminates that. Another good thing, a benefit of repeated measures, is that it limits the participants you need. Since you can have those participants do a multiple number of different things, you're able to require less participants to do things. So you don't have to have participants doing this test, and three different groups of participants to do three different things. You just have one group of participants doing those three different variables. One of the downfalls and one of the disadvantages to a repeated ANOVA, this is the same benefit. Potentially, you could have fatigue, as it's called, of your participants. They just either get tired doing all these multiple data points, or they might even figure out kind of what's going on because you're kind of doing the same thing with all of them. They may just be like, okay, I think I might figure this out, or they may just completely change their mind about something. One of the ways we control for this is just switching up things. A counterbalance is called. So giving one person one end of the research experiment and the other group the front end of it, and then switching them around. As with most any statistical test, there are assumptions. With repeated measures, there's a new assumption called sphericity. That is a test of variance between the conditions to see if they're equal. And the test that is indicating for this assumption is called Mauchly's test. How it's ran is, so if P is less than 0.05, null hypothesis is rejected, or the violation is, the assumption is violated. If P is greater than 0.05, the assumption is met. So as always, kind of just reminder before we start, or before you start actually running your repeated measures, always run your other assumptions. Even though there is the new assumption for this repeated measures, you still have all the other assumptions that ANOVA testing has. Your linearity, your normality, your homogeneity. So don't forget to always run those as well as sphericity. And again, we'll go over that new assumption later. So for what I wanted to look at, the variables I looked at was BMI at baseline, BMI at 1 year, post 1 year, post 2 year, post 3 year, and look at that over self-reported health status. And this was kind of the research question that I came up with and wanted to look at. Self-reporting can have a tendency to be biased because individuals don't want to report information about themselves that may not show them in the best light. So I wanted to test if participants report health status. If participants report health status in accordance with their BMI reported, self-reported health status is reported on a scale of 1 to 5, with 1 being excellent, 2 being very good, 3 being good, 4 is fair, and 5 is poor. Just kind of the reason why you might want to use repeated measures ANOVA. I want to look at the difference of BMI scores over from baseline to 3 years. So basically almost really 4 years worth of data points that I want these same participants to look at. And it can cut down on the unsystematic variances, especially since a lot of these participants did not participate at all for the data points. So what I'm going to do now is we'll go over to SPSS real quick, and I'll we're just going to kind of go over how you actually would run a repeated measures ANOVA instead of just having the screenshots for you. I figured this might be a little bit more helpful. So we're just going to get started. So you open up your data set. So I've already got that opened up. And so I know my data points that I want to analyze now. I've run my assumptions, looked at that. So what I'm going to do is we're going to go up here to Analyze. Click on Analyze. And I'm going to scroll down to General Linear Model. We'll open up Data Sets. I'm going to go over to Repeated Measures. It's going to open up the defined factors. So I have basically 4 independent factors that I want to look at, the 4 data points of BMI. So up here within the subject factor name, I need to give it a name. This is what's going to appear in my output. So I want something a little bit more than factor 1 to know. So I've already kind of done that already. I've done it right down here. So you can see when I click it, this is what I typed in self-health, and I've got 4 levels. The levels basically represent the different independent variables I have. So BMI at baseline is 1, BMI post 1 year is 2, post 2 years 3, post 3 years 4. So once you do that, you'll click Add, and it will show up down here and go down to Define. Now I can come in here and start defining my subject variables or independent variables. It's already got them, but let me show you how you would do it. So this is what it'll actually look like when you do it without, again, I've already done it, so that's why I had them in there. It'll have question marks next to all of them. Now it's important that you put them in the right order because obviously if you were to put them out of order, it would mess up your data. So BMI at baseline, that's the first one. So it goes in there, and it will just auto-populate down for you. So it'll just move down to the next one without you having to click over. So the next one. So here, and you click over here. Click on 3, 2 year, 4, click on 3. And so that's how you would do that. And then, since I'm wanting to look at self-reported health status, again, same thing. So I'll put it back over here. I scroll down on my self-reported health status, come over here and put it in there. Because I'm wanting to look, because again, there's 5 different health statuses within the self-reported health status that I want to look at as well to see what the difference is between those subjects. So you've got a few different options over here you can come and look at. Click on model. We're not going to be using that. That's what will pop up. Contrast, we're not worrying about that this time. Let's go around. Plots. So plots is something that we're going to look at as well, just because it'll be helpful to kind of graphically see what's going on. Obviously, you can always look at everything through the data, but looking at something graphically kind of just gives more credence to what your data is actually telling you in the numbers. So I'm going to put self-health down on separate lines and health 0 up here. So my self-health, again, is my BMI numbers. And then my horizontal axis is going to be my self-reported health status categories. So I click Add, and then I got my options of doing line chart, bar chart. I want line charts because I want separate lines to kind of show you a little bit easier, and line charts just tend to show up better with this kind of data. So I continue. Post hoc, we're not going to do anything with post hoc. I want to display the means. So I've got multiple dependent variables, but I want to deal with self-health because I want to deal with the BMI, my BMI means. So I click over, display the means. I want to compare the main effects within that. I also want to choose a adjustment because since I've got multiple dependent variables, I need a correction for that because again, my p-value could be skewed or construed with that. So I would choose a Bonferroni since that's the most commonly used one and we've used it before. Options, or as I want your discrete data to go back to. I choose also estimates for effect size and observed power, just because they're good things to report as well, because they can kind of show the effect size of your sample size and just the power of your sample size as well. Homogeneity you can choose as well. And then you click OK after you're done with it, and it'll spit out your output for you. And so now I'm gonna switch back here, and we'll kind of start looking at the output. So one of the first ones we're going to talk about is it's going to be the multivariate test. So again, we're looking at the self-health, which is your BMI numbers, and we're also looking at self-health again and against the health reported statuses. So what we're kind of looking at here, it's giving you different tests, but the main one that we're going to look at is the Wilks lambda. It's the most commonly looked at one. It's talked about in the book, and so it's just more commonly used. It's got a little bit more credence, a little bit more power to it. So what we're looking at here is we're going to look at the significance areas. So again, as significance normally goes, p is less than 0.05. So for the BMI numbers effect, the significance is, there is a significance there. BMI is necessarily within the multiplied against self-reported health status is not significant. So we would have to make the correction for later on down, or there's just not much significance there. So we will not be looking at that, but we're going to keep talking about it just to kind of show you how you report just a little bit more. And again, I talked about how I like to report the effect size, which is your partial eta squared and your observed power. Your partial eta squared, it just kind of shows how much, what's the effect size of your sample. This is obviously a little bit larger sample, but if it wasn't a little bit larger, this would be able to kind of tell you what the effect size is. And observed power one is the highest you can go. It's got very high power because it is a large sample. Another output that you'll get as well is, again, the test of separicity. I don't know if I'll ever be able to say that one, regardless of how many times I try to pronounce it. So for here, what we're looking at now, so this is just simply looking at the BMI numbers within this group. And if they are, the covariance between the, or the variance between them is equal. So what we do is we come down over here and we'll look at the significance column for that. So for here, as I mentioned before, P has to be, we don't want this to be significant. Basically, we don't want this to be less than 0.05. It's the opposite, kind of like Levine's test. So this is less than 0.05. So this does not meet the assumption. So what we're going to do from here is you would use the greenhouse geyser or the Hunfeld, or more commonly the G&G or H&F test. You would use these going down from here on out on different outputs to look at to basically report your data. So from here, now the next one that's going to show up is the test within subjects effects. So again, we've got self-health against, or BMI, and the BMI against self-reported health statuses. So what we're going to do here, actually not right, because I just told you like a little bit ago that it is not, separicity was not assumed. So what you would actually use here is right underneath it, the greenhouse geyser. And we're going to use that just because it is the more commonly reported test for if separicity is not assumed. So what you do instead, okay, so I'm going to back up and I want to show you how you would report this. So you still would look at it, the greenhouse geyser right here. So instead, it's going to be F. And your degrees of freedom, so you're not going to use 3 here like originally, but you're going to come down here and report the degrees of freedom with your 1.693, and then your error down here. So again, you're going to report from the G&G column, so 301.42. So okay, and again, the fall line over, so your F statistic. Your p-value, so significance right here is less than 0.05. And then you're also going to, I'm going to report the partial eta squared times their power. So that symbol is right here. And then my power. So that's how you would do it. And then again for self-help, again, it didn't fall, the assumption of separicity was not met. So again, you would report G&G just like I did for the other one up here. You report everything across. So another comparison that we're looking at, especially for something like this, is your pairwise comparisons. So what this is doing is that this is looking within the different self-reported status groups and showing, okay, which groups report different BMIs and what is the mean difference between those. So you can see here the category 4, or the status that's reported as fair. It's got the most significance, statistical significance, difference of significance between the other categories, between excellent, between good, and very good. And you can see the mean difference right here. Now, again, this is kind of where I want to go back to as well, is that you look at all these numbers and it gives you all these statistical significance, but you want to keep looking at you want to go a little bit further and like, okay, well, this is obviously telling me these numbers here. But I'm gonna pull up my descriptives as well, because I want to see, okay, what's my test is telling me there is a difference, but let me just really check that again just to make sure I'm not being something funny is being told over me. So again, we're gonna look at the fair categories, and I've got those in the red boxes, and then you're gonna look and see, okay, so it has across all the BMIs from baseline to post 3-year, it's got, and ignore the bottom 3-year there, it's got the most difference in between all of them. And you can kind of see, looking at your BMI or your baseline, there's a big significance between there's a difference between excellent, very good, and good, and fair. And then you can just obviously see from down there, there is a difference. and some of them may not be as big or as large, but there is still a difference that your data is telling you, and that you can obviously see right there. Again, this descriptive proves that that what your pairwise comparison tells you and what your within subjects test told you, that there is a difference. There is a significant difference. Just remember to look at everything and make sure the test results that are being reported to you make sense. And again, this is the line graph. Again, you can kind of see here too, even if you look at your scripts and you didn't really necessarily believe in so much, you can see right here that your self-report health statuses are on the bottom row, and your BMI is on the side. So as BMI continues to rise from healthy weight all the way up to overweight, obese, etc., the self-report health status basically follows suit. So as BMI rises, health status reported basically falls. So you can see like the people that reported poor are the ones that had a high BMI, and fair, and so on and so forth. So you can see this is why you use line, just because it shows a little bit better graphical data. So for the conclusion of this, I said that participants were aware of how their health was according to BMI numbers reported. As BMI moved from more healthy weight into overweight to obese categories, participants ranked their health status as worse. The results prove, but the results state there is a significant difference between the participants' reported fair health status compared to other participants, basically stating that the fair category of health status showed large significance between other categories. And again, if you go back and you kind of see, again, where fair jumps off compared to all the rest of them is much higher. The reason that poor is not really represented in this as much is that poor's really only got 3 participants across from baseline all the way to 3 years. And it's not even represented in 3 years. So that's the reason why, even though on this graph, poor looks astounding, like it should have really a big difference, there's only 3 people, so you can't really include those results because there's not enough statistical effect to really show that. So the data is a partial indicator that participants in the study can accurately assess their health. And recommendations could be made that participants be able to self-report other data should the need arise. The researchers see to have that. So that's kind of all I have for you today. Thank you for listening in and participating, and have a good day.